Hi, this is Mia, and I am presenting my final project for 15463 Computational Photography at CMU. My project title is 3D Photography Using Context-Aware Layer Depth Inpainting, and it is based on this paper. So our task is, given a single RGB input image, we want to generate a 3D photo. We begin with processing our RGB input image. We run a depth map generation model and then use a bilateral median filter to sharpen the depth map generated to detect discontinuities in the pixels. We want to clean up these isolated discontinuities in order to link them into a collection of connected depth edges. These linked depth edges form the basic unit for our inpainting process. We represent the input image as a LDI, layer depth image. So a layer depth image contains multiple depth pixels per pixel location. We want these depth edges in order to construct our context and synthesis regions. Here, the context regions are shaded in blue and synthesis regions are shaded in red. For each specific depth edge, they have their own context and synthesis regions. So at the very beginning, we start with a fully connected LDI. Here we have a depth edge marked in gray. We first cut the LDI pixel connections across the edge, forming a foreground silhouette and a background silhouette. For the background silhouette, we create a context region and a synthesis region of the new LDI pixels. Then we merge the synthesized pixels into the LDI. Here is the overview of our inpainting process. Given the color, depth, and extracted and linked depth edges as inputs, we go over all of the edges and randomly select one of the edges as a subproblem each time. We first inpaint the depth edge in the synthesis region using an edge inpainting network. We then concatenate the inpainted depth edges with the context color together and apply a color inpainting network to produce the inpainted color. Similarly, we concatenate the inpainted depth edges with the context depth and apply a depth inpainting network to produce the inpainted depth. So here are some pretty good results. And here are some not so good results. I wanted to understand why some inputs fail to get desirable outputs. I realized that the common problem here is the depth map we generate can be an inaccurate representation of the scene. How can I make this better? So I plan to add something in the pre-processing pipeline, and in particular, I decided to work with specular scenes. So if the specular highlights are what's causing us to generate inaccurate depth maps, removing them should enhance our results. And that's what I wanted to do. So I found this paper called Real-Time Specular Highlight Removal Using Bilateral Filtering, and their method is based on a key observation. The maximum fraction of the diffuse color component in local patches in color images changes smoothly. So I implemented their algorithm according to the paper and wanted to incorporate this subroutine in the pipeline by generating the depth map from the fuse image. But unfortunately, it did not quite work out just yet. So I want to continue working on this and actually add it into the pipeline. And I want to see if I can get better results for scenes with specular objects. That's everything I have for now. And thank you so much for listening.